Hi, everyone. My name is Katharine Schwab. I'm an assistant managing editor here at Forbes covering technology, and I'm so excited to be here today with Andrew Feldman, the co-founder and CEO of Cerebras, which is an AI chip company. It's about 8 years old and is planning an IPO for later this year, which is exciting. So, Andrew, thanks for joining us.
Thank you for having me.
Let's talk about chips and AI, which is really hot right now. Normally, the first company that comes to mind when you talk about chips and AI is Nvidia, obviously. Can you talk about how Cerebras's chips and kind of approach to chips is different from Nvidia?
Sure. Nvidia has its heritage in graphics. They pioneered a part called the GPU, which stands for Graphics Processing Unit. AI work is slightly different. And we began with a clean sheet of paper and designed a chip and a system and software just for the purpose of AI. And as a result, we're orders of magnitude faster, and we use a tiny fraction of the power per unit compute.
Okay, so in terms of practical speed, what does that mean for if I know you're not powering ChatGPT per se because that's OpenAI, but
Sure.
How much faster are we talking in kind of layman's terms?
If you ask, say, DeepSeek, which we are serving right now, if you ask DeepSeek a question, and you ask the same question to OpenAI O1 Mini, one of their top models, we will be about 57 times faster to get you an answer. So,
Okay. That's significant.
it's a lot. And if you compare head to head with one of, say, Meta's models, Llama, 70 billion parameter, which is one of the most popular models, will be 70 times faster. So it's head and shoulders faster. The difference for the user is between a second and 24 seconds to get an answer back. Right? That's a meaningful amount of time when you're waiting for a response.
For sure. Okay. So my understanding too is that your chips are massive, like the size of a dinner plate. Can you explain why are they so big? Why did you make that decision?
Sure. AI at the compute level is comprised of two challenges. You have to do a lot of calculations, and you've got to move results frequently. And it's unusual in that it requires the movement of data constantly. You do some calculations, you move the results. You do some calculations, you move the results. What we saw was a large portion of the time and energy consumed was in the moving of data. And by building a big chip, we could keep all this information on a chip where the calculations are done more quickly, where data is moved more quickly, and it uses less power. And so it was a solution to the fundamental problem of AI compute.
It's funny because everyone, I think the conventional wisdom, right, is that chips get smaller and smaller and smaller as technology advances. But here we have a massive chip
Right.
that's helping AI run faster.
So I think the important thing is to remember all chips begin on a wafer. They begin on a 12-inch diameter circle of silicon, and they're then chopped up into little things about the size of postage stamps. But for a problem like AI, you need hundreds or thousands of these, and so then you string them together. So you begin with Humpty Dumpty, you cut it apart into little pieces, and then you glue it together with string and sealing wax, with switches and with fiber. And all of that takes power and cost and adds time. Whereas if you kept it on the whole wafer, you could do away with huge amounts of auxiliary infrastructure and the time they consume. And so that was an observation we made. Now, this applies to AI work. Obviously, a big chip is not the right thing for a phone or for your car.
Right.
It's for a particular type of problem that has a great deal of communication required.
Okay, so But this is very different from the kind of chips that Nvidia is making. How, and of course, Nvidia is one of the biggest companies, the most valuable companies in the world right now. How do you think about competing with Nvidia and convincing all of Nvidia's customers that they should become your customers instead?
Look, Nvidia is an extraordinary company. They've had a great decade for sure. I think you convince a customer that you can solve their problems for less money, in less time, and for less effort. And so we've been able to do that for a whole range of their customers like Mayo Clinic, customers like GlaxoSmithKline, customers like Total Energies, leading customers around the world now use our equipment to do their training and to do their inference. So that is, training in AI is how we make AI, and inference is how we use AI. So they're consuming our hardware both in the making of AI and in the using of AI. And they've chosen us because we are faster, we use less energy, and therefore have a better total cost of ownership.
So you mentioned earlier that you are also running DeepSeek, which has, of course, made waves in the last week and a half or so.
You think?
Yes. Definitely a big moment.
Even my parents, who know nothing about AI, are blogging about DeepSeek. I mean,
getting random texts. What is this DeepSeek thing?
Yeah, people coming out of the woodwork. Everybody's commenting on DeepSeek.
Yeah, so huge upheaval, in part because they were able to train their most recent model, so they say, with significantly less in resources, and Nvidia's stock crashed and everyone's talking about it. So as we reported last week, you and your company were really celebrating, even as this was causing kind of widespread consternation about, was it actually the right thing to pour so much venture capital money into American AI startups who are then spending, hundreds of millions of dollars, billions of dollars training models? Why has this breakout been so exciting for you and Cerebras?
Well, first, let's understand what DeepSeek is. DeepSeek is two models, a parent model called V3. This is a giant model. And then there's a distilled version. There's a version that's smaller that tries to capture some of the essence of the giant model, but is easier to work with. DeepSeek made available on an app their models, and they also put them in the open source community. And they did that with a very generous and permissive license. And so if you use their app, you're sending your data to their servers in China. You have to make your own judgment on whether that's wise. But some of us took the open source model that they published, and we began serving it on our equipment in the US. And we weren't the only ones. The guys at Perplexity did it, and the guys at Together and Fireworks, a whole collection of companies did it. And there was tremendous demand. And there was demand because this was a good model. And it was the first open source model that allowed reasoning. So it was better at math, it was better at coding, and it was better than most of the other open source models.
Including Llama? How does it stack up against Llama in your estimation?
Their distilled version can make Llama even better. So using their methodologies, you can improve Llama. And that's one of the models we serve. It's called DeepSeek 70B Llama, where you take the essence, some of the learnings out of their model, and you imbue the meta model with that learning, and the model performs extremely well. It is one of the top performing open source models right now.
Okay, so zooming out, what do you think the creation of this model in China, now being used by American companies, the open source version being used by American companies, what do you think this means for the industry at large?
Look, I think Sometimes in Silicon Valley, we get a bit myopic. It turns out that there are good universities in India, in Europe, in Dubai, in Abu Dhabi, and in China too. And their engineers are excited and want to work on AI projects just like our engineers and just like engineers all over the world. And that they're capable of taking open source and building on it. The DeepSeek models built on other people's open source work that had been put into the community. I think, the US regulations limited their amount of compute that they could get. They used some innovative techniques, some of which they pioneered, others of which they extended the work of others. I think they published their work in a fairly open manner. They made it available through the open source community, all of which are positive. I think they teach us that all good things don't come out of Sunnyvale or Santa Clara or Palo Alto or San Francisco, right? A lot of good stuff has come out of other parts. Mistral is building great models in Paris, and Cohere is based in Canada, has built great models. Great models have come out of the UAE, Jace in Arabic, and the Falcon models. The worldwide ecosystem is pushing AI forward, and China's no exception. We should not have been surprised. It was not the first good model to come out of China. Some 6 or 8 months earlier, Qwen hadn't come out of China, and that's a family of 100 models from Ali. And so that's sort of by way of background. I think the reason Nvidia stock got hammered is, I think, a fundamental misunderstanding that has reared its head again and again in the public markets. For 50 years, each time in the compute industry, we've gone faster, we've reduced price, we've made the market bigger, not smaller. And the first step, the first response by the public markets has been sell. They made the market smaller. I think what DeepSeek showed is it's not just OpenAI and Anthropic and Cohere and Perplexity and Fireworks, not just 8 or 10 companies that can do really interesting work, but it can be done in China, it can be done in Europe, it can be done and should be done in India, it should be done in the Middle East, that this work can be done at reasonable cost with 100 or 200 really smart people, can produce extraordinary results. That makes the market bigger, not smaller. And I think there are very few healthy markets that have one dominant player or 2 dominant players. That's just not the definition of a healthy ecosystem.
Right. So I guess to kind of return to the idea of conventional wisdom here within the AI world, it has been largely that more data, more compute equals better AI. And as a result, you got to spend a lot of money to buy all that compute, to obtain all of that data, to make these very, very expensive AI models. So what I'm hearing from you is that by creating models that are much cheaper, that lowers the barrier to entry and makes it much more available to everyone to use.
Of course it lowers the barrier to entry. I mean, I don't think anybody would say this model was cheap to train. I think there's general agreement that it cost a fair bit more than they reported, and that it cost a fair bit less than others who had trained models of similar size. So they did good work. They made it more efficient, but they used more than they said they would use. I think the other thing is this family of models, these reasoning models, use more compute during inference. When you use them, when you ask them a question, it consumes more compute for them to produce an answer. Now, the answers are better. They're more accurate. But they use more compute to produce the answer. So what you might be seeing is a small shift from compute being dominant in the training world to us using a great deal more compute in the inference world. And I think that's in line with what most of us think is happening, is that as the number of users grow, as the frequency with which users use these models, the amount of compute consumed with AI goes through the roof.
And I'm sure that's very good for your business.
We were excited by it. I think, and ask yourself this question, a year ago, how frequently did you use an AI model? And now, how frequently do you use it? Does your marketing team use it every day? Do they use it 10 times a day? Does your mother use it to send?
Not yet.
Well,
I'm working on her, but not yet.
my mother uses it to send a little note to the retirement community. It's remarkable, and I think as it proliferates, as it diffuses throughout the population, as usage goes up, the amount of compute needed goes up. People are unwilling to wait 20 seconds or 50 seconds to get an answer. They want it fast, and that's what we're the best in the world at. And so the whole ecosystem is moving forward at a tremendous rate, and that's good for everybody.
So a lot of this conversation has also focused on the kind of US versus China AI race narrative. Can you give me your perspective on how much of that is kind of overblown, and how much of that is kind of legitimate concern that, Chinese, there's a real national security threat if China is building better models than American companies?
I think with any new technology that is powerful and immature, it is important that the U.S. be a leader. And I think the Chinese government has invested in its startups. It has been a backstop for venture capitalists so that if they invested and the investment turned to nothing, the government would refund their money. And so I think the Chinese government has invested heavily in this. I think that is not our way in the U.S. Our way is to use venture capital and other techniques. I think the government has put some money in the CHIPS Act, which is important. We need a chip ecosystem, and the chip ecosystem sits underneath the AI ecosystem, right? You use chips to make the AI and to use the AI. I think it is important that in the U.S. we are leaders in important emerging technologies, especially those that have the enormous potential that AI has.
Yeah.
I think that's true for quantum too, and a collection of other emerging technologies.
Yeah. Chips, though, are certainly a hard business, which...
It's a hard business.
As you said, having some government help through the CHIPS Act, though, of course, Trump has kind of come out against that. So we'll see what happens.
The CHIPS Act, it was a good start. I mean, Microsoft announced that it would spend $80 billion on CapEx this year, and the entire CHIPS Act to help support an entire industry was only $40 billion. Right? So
good context and perspective.
Right.
Yeah.
That's sort of the perspective, that there will
Right.
be individual customers who over the next 2 years spend more buying compute than the entire CHIPS Act. And so it's a start, but it needs to be followed on, and additional support by the government to keep manufacturing and chip making and chip packaging in the U.S. would be really appreciated, and I think helpful for the ecosystem.
I want to switch gears just a little bit to kind of hear from you about your personal reflections as an entrepreneur, starting the company, 8 years ago, and why this felt like the right moment to look toward an IPO.
Let me talk about being an entrepreneur. I am a professional David in the battles with Goliath. This is my fifth startup. And about the 18th year, I've been a CEO. I think there are some people who are passionate about doing new work. The old cartographers used to draw these maps, and where they didn't know what was there, they wrote, "Here be dragons," right? And some of us don't want to be near the coast. some of us want to do engineering work where the dragons be. And we want to every day use our brains and our insight and our creativity against the muscle of giant companies. And that is our passion. And we like to surround ourselves with people who have similar passions. And we are generally not afraid of failing. We're afraid of being ordinary. Right? We're more afraid of not doing the extraordinary, of pursuing the mediocre, than we are of failing in pursuit of something truly extraordinary. Our chip, for example, this strategy had failed for every company for 55 years. It had been tried by IBM. It had been tried by Texas Instruments. It had been tried by one of the fathers of the field, Gene Amdahl, and failed. And we believed we could do it. And the first day at work, the founder stood there staring at our machine running, doing something that nobody in the history of the computer industry had ever achieved. And that's why you should do this, to be where the dragons are, to build things that other people haven't built, and to know that feeling of creating.
Very poetic and beautiful.
Well,
I love that.
I'm not sure it's
and
poetic. It's
dragons analogy on the ancient maps. Okay, well, I actually think that's a lovely place to stop. Thank you so much for your time, Andrew. It's been a pleasure to chat with you. I'm sure we'll chat more in the future. And best of luck with your massive chips.
Thank you. From all of us at Cerebras, thank you to Forbes for having us on your show. We very much appreciate it.
Thanks so much.